Is this good angle?
Yeah, it is good. I see everything.
Okay. Let me know.
Yeah, good.
Okay. Hey, Dr. Walker, this is me and Davis, tutorial number 4. We went ahead and did problem number 1, which is where we're trying to find where light escapes the prism. We were told to choose our own value for N2. We chose 1.5 because 1.5 is a good number. We also know that N of air is 1, so we'll keep those numbers in mind when we use this problem. We're also told that it comes in perpendicular to the prism. So we're going to use that information shortly and I'll explain everything. But the light comes in, we know it's perpendicular to the prism, so we know it makes a 90-degree angle. It touches the bottom. Well, now we want to know, does it have total reflection or does it escape the prism? So in order to do so, we need to find first the angle of incidence. To do this, we went ahead and knew, because the problem gave us, that the angle 1 over here is 70 degrees. We know that this is 90 degrees. So, because it's perpendicular and we're told that from the problem, so we use 180, since it's a triangle, minus 90, minus 70, we get 20. 20 is our angle over here, but that's not technically our angle of incidence, because our angle of incidence is between the light ray and the normal, which means it's actually 90 minus 20, and you get 70 as our angle of incidence, 70 degrees. So I'll put that for you here, just so you have it. So now we need to go ahead, and since we found our angle of incidence, we need to find if it will have total reflection or not. So we use Snell's law. We use we need to find a critical angle, I'm sorry, so we need to use Snell's law anyways. We do N2 over N1, and then as you simplify it, it turns into inverse sine of N2 over N1, which we had 1 and 1.5. And we got a critical angle of 41.81. The issue though is our critical angle is less than our angle of incidence, which does mean total reflection, which means the light will not escape at this angle. But what that does mean is that it will reflect at the exact same angles that it came into the prism with. And in doing so, we know that this is 70 degrees once again, this is 20 degrees. So these are two things we do know, because again, the normal's here and it needs to be perpendicular to make the 90 degrees. We were given that this angle is 45 degrees. These are two very important things. We know this is 45 degrees. We know this is 20 degrees. We're going to see if the light escapes here or not. So in order to do so, we did our 180 minus 45, because again, it's a triangle, so 180 minus 45 minus 20 degrees. You get 115 as the overall angle here. That's not necessarily the most important part, as we still need to find the angle of incidence, which we said is the light towards the normal. And we know that it makes a perpendicular line because it's the normal towards the prism's outline, so we know it would actually be 115 minus 90, and that gets you your 25 degrees over here, which is our angle of incidence for N2 on the interior, to see if it goes out. And we do the same exact thing to see if our angle of incidence is greater or less than our critical angle. So all we do is put them next to each other. Our critical angle, which we found out earlier, is 41.81. We know that it indeed is greater than our new angle of incidence, which is 25. So we do know refraction occurs at this point and light will escape the prism at this point. Now we just need to find the certain angle and direction it will move in. So in order to do so, we use Snell's law. N2 sine 2 theta is equal to N3 sine 3 theta. Now when you simplify it, get everything done, we get to we need to find our theta 3, which is the light escapes outside. We need to see what the angle is. We get inverse sine of 1.5 sine 25, as we know our angle of incidence. We know our N2, as we said, in the prism is 1.5, and it reverts back to, that's 1, because it's moving back to the air, and the air has an N of 1. So that is why we got our value 1 here, 1.5, like we said, we chose it. Our sine 25 we found was the angle of incidence. We do the inverse sine of all of this to get our angle 3, which we ended up getting 39.34 degrees. This is the angle that light escapes the prism. We also know that it bends away from the normal due to it coming from technically a glass prism structure to air. So thank you.